Hello everyone and welcome back to Nunley Math. I'm Aaron Nunley. Thank you so much for joining me here today in the very last in our series of videos on exponents and scientific notations. We spent a lot of time exploring exponents and exponent rules, and then we followed that up with a series on what scientific notation is, and then a lesson on multiplying and dividing when we are dealing in scientific notation. Our very last lesson today is on adding and subtracting in scientific notation. I'm not going to waste a whole lot of time today. We're going to hop right in because at this point we should be getting pretty good at understanding how scientific notation works, and these last few pieces should fit together very nicely. Just in a quick review, scientific notation allows us to write numbers that are very large or very small in a way that's easy to work with. We want a number that is between 1 and 10 multiplied by 10 to a certain power. If we have really big numbers, like 52,000, we want to write it so that in scientific notation our decimal is moved 1, 2, 3, 4 places, giving us 5.2, and then to turn the 5.2 so that it is equivalent to 52,000, we're going to multiply by 1, 2, 3, 4 decimals. 5.2 times 10 is 52, times 10 again is 520, times 10 again is 5,200, times 10 again is the 52,000. In the case of very small numbers like 0.00003 or 3/100,000ths, once again, we need this decimal to be in a position where our number is between 1 and 10, so we move it 1, 2, 3, 4, 5 places over so that instead of 0.00003, we have 3 by itself, and then we notice that that decimal had to move 1, 2, 3, 4 places. But if I multiply by 10, this 3 is going to get bigger, not smaller. So instead, I need to multiply it by 1/10, so that it is smaller. The way we multiply by 1/10 is we write it as 10 to a negative exponent. 1, 2, 3, 4. This is going to be 10 to the negative fifth. Again, I ran through that very, very quickly because I talked about it in the last 2 lessons. This is just a quick review to keep our mind working in the right way when we're dealing with scientific notation. So let's take a look at this. Adding and subtracting in scientific notation. So I'm going to start you off with 52,000 plus 3,500, and we're going to try and add these in standard form. So I write them both down, 52,000 plus 3,500, and I get 87,000, right? Well, hopefully you realize that makes no sense. That's complete nonsense. We don't add that way because when we do addition, it's very, very important for us to have our place values lined up. Take a look right here. You have 2,000 plus 500 giving you 7,000. That doesn't make any sense. Here you've got 50,000 plus 3,000 adding up to be 80,000. That doesn't make any sense either. No, when we learned how to add way, way back in elementary school, we learned that our ones column has to be lined up with our ones column. Our tens have to line up with our tens, our hundreds and our hundreds, thousands, our 10,000s and 10,000s. Or a better way to say that is you have to make sure that everything is lined up right next to that decimal point. So that when we add these together, my 2,000 and 3,000 make 5,000, and that makes sense. Now, this is not in scientific notation, but it does help us in understanding how we're going to have to add in scientific notation. Take, for example, 5.2 times 10 to the fourth and 3.5 times 10 to the third. If you are extra observant, you might have noticed that this is the same thing as 52,000. And if you're extra observant, you might have noticed that this is the same as 3,500. So I'm actually adding the exact same numbers, but I'm doing it in a different form. And I do this to illustrate for you that when we go to add these together, we can't just do 5.2 plus 3.5 and get 8.7. The reason we can't do this is the exact same reason why we couldn't do it over here. And that is, even though it looks like this is in the ones place and the ones place, because of the exponents on the other side, we know that this 5 is going to get pushed out 4 places. And this 3 is only going to get pushed out 3 places. In other words, the 5 needs to be over here, and the 3 needs to be over here. These do not line up, even though at first glance it looks like they do. We have to adjust this to be more like this, where we have our decimals in the same spot. And the way we're going to do that is we're going to take this 10 to the 4th and this 10 to the 3rd, and we're going to change them so that they match. Now, the easiest way to do that is to take the smaller exponent and turn it into the larger. In other words, I want to take this 3 and I want to make it into a 4. That means I need another 10 right here. Do you have any idea where I could get that 10? I'm going to steal it from over here. You see, I'm going to take this 3.5 and I'm going to steal a 10 from it so that I have 0.35 times 10. Remember, multiplying by 10 would move that decimal. And I still have my 10 to the 3rd. I've rewritten this portion right here so that I have an extra 10. Because if I do that, this becomes 0.35 times 10 to the 4th. This has the same exponent as this, which means now my numbers are lined up. If I had to move this decimal 1, 2, 3, 4 places, and this one 1, 2, 3, 4 places, the 0 and the 5 would still line up. The 2 and the 3 would still line up. The 5 and the 0 would still line up. In fact, you can see that right here. The 0 and the 5 line up, the 2 and the 3 line up, and the 5 lines up. Now I can add these together. Now, just like in addition over here where we said 0 plus 0 equals 0, this is just keeping track of how many zeros should be written here. I should have 0, 0, adds up to 0, 0, 0. This I'm not going to have to mess with at all. I'm just going to bring that down. But 5.20 and 0.35 makes 5.55. Notice I did not change these or add these exponents together. These exponents get added together if this was multiplication, and it's not. Now that's a really long, complicated way of explaining what I need you to do. Once you understand the need to do it from this and this, we can skip out on a lot of those intermediate steps and focus right here. We want to take the smaller exponent and turn it into the larger exponent. Let me erase all of it. Let's try another one. 4.24 times 10 squared plus 5.9 times 10 to the 4th. I'm going to write that vertically real quick. If I were to write this vertically, the temptation is going to be to do the 4 plus the 5. The problem is this isn't really a 4. It's times 10 squared. So I'm going to move that decimal 2 places. This 4 is a 400. This is not really a 5. This is actually a, move the decimal 4 places, this is actually a 500. So I can't take 4. Let's try another one. 4.24 times 10 squared plus 5.9 times 10 to the 4th. I'm going to go ahead and write that vertically, and when I do, the temptation is going to be to say 4 plus 5 is 9. The problem is this isn't really a 4. Because it's times 10 to the 2nd, that decimal should be moved 2 places over. This is a 400. And down here, this isn't a 5. Because of this 10 to the 4th, this is actually a 50,000. So I can't take 400 plus 50,000 and end up with 900 or 9,000. Instead, I'm going to have to rewrite this problem so that my exponents match, and that's going to put everything in the right place value. Now, it's usually easier to take the smaller number and turn it into the bigger exponent. So I want to take this 10 squared and rewrite this so that this is 10 to the 4th. I need 2 extra 10s. Any idea where I can get those? Well, I'm going to steal them from right here. If I steal a 10 away from this, this is going to become a 0.4. If I steal a 10 away from this, it's going to become a 0.04. You see, this expression right here, that number right there, is the same as 0.0424 times 10 squared. In fact, you could multiply it back together and see it's 4.24. But we also have this times 10 squared at the end, which means this is 0.0424 times 10 to the fourth. Notice it matches now, so I can bring that 5.9 times 10 to the fourth over, and if I line up my decimals, I can add this together. 59424. Notice there's an extra decimal in there. That's a little typo. I'll get rid of him in a second. Times 10 to the fourth. Not too bad, right? The most difficult part is realizing the need for the conversion and then taking the time to do the conversion carefully. Let's do one more. This time I'm going to make it into a subtraction problem. I'm going to recommend you pause the video, see if you can do this on your own using what we've learned. I'm going to keep right on going, assuming you've done that. I'm going to set this up as a subtraction problem, but I run into the exact same issue that I ran into before. This is not actually a 3 because of these 7 1/10ths. Remember, -7 is use the reciprocal. So this is actually a really tiny number. And this one only has a -5. So the 3 and the 2 are definitely not going to be in the same spot. Now it's usually easier to take the smaller exponent and change it to the larger. Keep in mind that -7 is smaller than -5, so I need this to go up 2 places. Where do you think I can steal 2 10s from? You're absolutely right. I'm going to steal those 10s from over here to make those match. If I steal 1, it becomes 0.3. If I steal 2, it becomes 0.0362. Now, don't forget you still have this 10 to the -7 over here, and when I combine those, now I have 0.0362 times 10 to the -5. I'm going to bring over the other problem. Make sure your decimals are lined up. That's important because now that these match, these are going to be in the same spot. And then we're going to add these together. Now this can be a little tricky. 0.362 is the same as adding the opposite of -2.4. So I'm going to add the opposite of this. This is a little tricky. I'm not going to get into addition of integers today. Just remember you take the number further from 0 minus the number closer to 0, and then you keep the sign of the number that's further, and you get -2.3638 times, notice that the exponent on the end stays the same. Put a box around that. Now, this conversion can be just a little bit tricky. If you're struggling, if you'll go back and watch it a couple more times, hopefully it will begin to make sense. But just know that this is probably the most difficult portion of the scientific notations unit. So that's really all I have. Take your time with this. Make sure you're showing your work. Don't allow yourself to get overwhelmed by skipping steps, okay? As always, I do thank you for joining us. I wish you all the very, very best of luck. You all take care of yourselves, all right? Bye-bye.